That's what this slide said, right? If your A is positive, which it is for us, the range, it's going to be an interval from the y coordinate of the vertex to infinity. Oh, sorry, I went too fast. So in this case, the range is going to go from minus 11 to infinity. So that's what the range is. I mean, we'll write it again shortly, but again, I'm just trying to show you that we actually know a lot already. All right. Are there any questions so far? Okay. But now let's get the x-intercepts. Again, the x-intercepts, we have to solve the equation. Let me see if I can draw it out. I'm just drawing it out like this because this was an issue in the other class. We have to solve the equation f of x equals 0, where f of x here is a quadratic function. Okay, so let's use the quadratic formula. I mean, yes, you could try factoring it, but let's just dive right into the quadratic formula. In this case, your A, as you can see, well, as before, is 2, B is 8, C is negative 3, okay? Okay, now for the x-intercepts then, right? We have negative B. We're using the quadratic formula. Excuse me. We have negative B plus or minus the square root of B squared minus 4 times A times C over 2A, which is negative 8 plus or minus the square root of 8 squared minus 4 times 2 times negative 3 over 2 times 2, okay? Which, of course, is this. You know, you work it out, you end up getting this here. Remember, there are two solutions here, negative 8 plus radical 88 over 4. The other one is negative 8 minus radical 88 over 4. I mean, I know the numbers are decimal, so I would just, you know, I use the calculator, mostly because the square root of 88, you know, it's not a perfect square, so it's not the best number. That makes sense. But now we have enough to make a graph, although I drew it in GeoGebra, but you could graph it by hand. Again, we know the vertex is this point, negative 2, negative 11. We know the axis of symmetry. I didn't draw that. Let me draw that. I'm going to draw it as a, see if I can draw it right, as a dashed line. Like so. Okay. Again, I mean, it's kind of hard to draw. It's kind of hard, it may be hard to visualize since I did the best I could with this dashed line. But again, the idea is you want to imagine being able to fold the graph about this dashed line, and both halves of the graph should match up. We also have the y-intercept here, as you can see. The x-intercepts, I did plot them. Remember, the y-coordinates are going to be 0 there, mostly because they're on the x-axis. And as before, the range is minus 11 to infinity, right? Again, you can see that if you were to move horizontally to the y-axis, you'd be at 11. And even from the graph alone, you can see that, you know, drawing from the graph a horizontal line to the y-axis, like see. Hopefully you can see that. I mean, here I'm drawing to the right of the graph, but that's okay. Even though the graph is also over here, you can hopefully see that you're going to get everything, every number, every part of the y-axis above negative 11. So that's what the range is. All right. Are there any questions on this? I mean, you do want to be able to sketch it by hand, even though we have things like GeoGebra, Desmos, graphing calculators, but it's still good to be able to graph it by hand though. Okay. All right, so let me start at least the next example. So we have, a different one as you can see. As you can see, we have negative x squared plus 6x minus 3, right? Okay, so what's a, b, and c in this case? Well, again, a is the coefficient of x squared, right? B is the coefficient of x. So a is negative 1, b is 6, and c is minus 3. So we have x now is minus b over 2 times a, which as we know is minus. So in this case with our a and b, we have minus 6 over 2 times minus 1, which is 6 over 2, which is 3. Okay, so we know that 3 is the x coordinate of the vertex, and the axis of symmetry is actually x equals 3. But to get the rest of the vertex, we need the y coordinate, right? Remember, let me see if I can get to it quickly. Right here, the vertex is this, right? So we have that. So, here we go. Wait, no, I think I went too far. Here we go. Sorry, went too far. So we have f of minus b over 2 times a. That's f of 3, right? Okay, so again, we're plugging it in, right? We're plugging in 3 into our function. As you can see, we have minus 3 squared plus 6 times 3 minus 3. So that's going to be minus 9 plus 18 minus 3. That turns out to be 6. And you can see that we have a lot of nice information, right? We have the vertex, 3, 6. We have the axis of symmetry, x equals 3. We know the y-intercept is just f of 0, which is negative 3. And again, since a is negative, we know the graph has to open downward, right? So the graph we know has to do something like this, right? The vertex is going to be on top, so to say. See if I can draw this, right? Oh boy, close enough. So that's what the vertex is going to be, right? So we know a lot about the graph already. I mean, really all we need now is the x-intercepts. And the range has to go down to minus infinity, right? So there we go. The range is going to go from, oh wait, no, that's not right. And we'll do it next time, out of time anyway. So we'll start from this example next time, okay? I might start at the beginning of example 2, but we'll see.